Welcome to Maths with Bob. Today we're looking at generating some formulas for the volumes of solids of revolution. Okay, we're just going to have a bit of a look at how we can develop the formula. Well, the first thing is we're going to rotate this yellow area around the x-axis. So it's going to, let's have a look. It's going to basically generate a volume. It'll be a bit like this. Let's have a look. Okay, so it'll be a bit of a bowl on the side shape. Okay, so it'll be, that area will scribe out as it moves in a circle a volume, and we need to work out what the volume is. Now, the first thing we can see, hopefully, is that the cross sections are in fact circles. Okay, they are pi r squareds. The radiuses are in fact the functional heights at the particular value. For instance, at 5, let's actually see what is the, okay, say when r is equal to, say, the x's value is in fact 5, that the r value, or the radius, will in fact be f of 5, which in this case is, say, what's that? 25 and 1 is actually 26. So the radius is actually going to be 26 when the x value is 5. So let's have a look over here. When the r is, say, when the x value is 1, the radius is f of 1, which would be 1 squared is 1 plus 1 is 2. So over here, we'd have that the radius is in fact f of 1, and it would in fact be, the radius would in fact be 1 squared 1, and so 2. So this radius would be 2 down here, and this radius here would in fact be 26. Okay, now let's have a look at how would we, well, let's try and first of all estimate how we would find the volume of this. Okay, let's just do a bit of an estimation. Okay, so the first thing is, let's look at, say, a point here, 3, 2 units away from 1 and 5. And let's draw some cylinders. So let's actually go over here, and we're going to draw a cylinder here. And let's actually go back from 5 back to this point. Okay. Okay, and we're going to create a bigger cylinder here. As you can see, that would be a very rough estimate by adding these two cylinders' volumes together. Now, what is the height or the width of these? So if I just put, this is the actual, you can see here the height is going to be, or the width is actually going to be 2 in both cases. So let's actually work out what the volume would be. Okay. So let's actually go over to the side and say, okay, the volume is approximately, obviously in this case, so it's going to be pi r squared. For the first one, it'll be f of 5 squared by the height. In this case, it would be in fact times 2. Okay, plus obviously the other one, pi, that's going to be what? F of 1. Okay, squared times its width, which would be 2. So you can see here we have to basically square the radiuses, multiply by pi to get the area of the circle, then multiply it by the width or the height. We push it through space to generate the volume. Now, okay, so basically, hopefully we can see that we could take a pi out of this. We can see, okay, so let's have a look. We could take a pi out. We have the functional values squared times height. Now, just what we normally would do is we'd say, okay, let's have a quick look at the height is actually this thing here. Okay, this is actually, we're going to change that to a delta x, or change in x value, or dx value. So these are delta x values. So when we put all this into the formula, okay, we're going to say that the volume, okay, is equal to, now we're going to take the pi out as a common factor. We're then going to sum all these cylinders, which we're going to shrink their widths, and we can do this with the Riemann sum by increasing the number of cylinders, or letting the number of cylinders head off to infinity, and hence the width of the cylinders would in fact shrink. And if we do this, we get the exact value for the volume, which is now going to be from 1 to 5, and you can see here it's the radius. Now the radius is actually the functional value at the point, and we do this like this. We say actually, okay, so at any particular value x, its radius would be f of x, and hence the radius squared would be f of x squared. and the width would be a small change in x, delta x. So this will actually give us the formula, okay, for the volume. So let's actually try and work this out. Okay, well, we now need to substitute in f of x, which we might be able to see is, let's have a quick look. Where is f of x? Actually, it's a bit hard to see, but here it is. It's the y equals x squared plus 1. So we need to square that, so we need to square this out. So we need the volume is going to be equal to pi integral from 1 to 5 of x squared plus 1 all squared dx. Okay. All right, so we're going to need to expand that out. Now, okay, what would that be? Okay, so let's have a quick look. Okay, so the volume would then be, okay, let's expand it out. So the volume would equal pi, now it becomes, still from 1 to 5, x squared plus 1 all squared is x to the power 4, plus there's going to be 2 lots of x squared plus a 1 times a 1 plus a 1, and we have to integrate all those bits and then evaluate them from 1 to 5. Okay, so let's have a look. Okay, so the volume would equal pi. Now we have to, let's work all these out. X to the 4, so it's x to the 5 over 5 plus 2x cubed over 3 plus an x. Okay, evaluate that from 5 to 1. Okay, then we have to type all this into the, well, first of all substitute it all in. Okay, we'll get what, 5 to the 5, so let's actually do this. That's the pi, lots of 5 to the 5 on 5 plus 2 lots of times 5, now it's cubed over 3 plus put in the 5 for the x. Now we have, I'll put that around brackets. So we've actually fed the integrand, or the integral, or the primitive function of x to the power 4 plus 2x squared plus 1, which you can see here is x to the 5 over 5 plus 2x cubed over 3 plus x, where we fed it the 5. Now we have to feed it the 1. Okay, and we get 1 to the 5 on 5 plus 2 times 1 cubed over 3 plus just ordinary 1 here, and we only need to evaluate all this. When we do all this, we can see we have to work this out, so it works out to be 711.47 corrected 2 decimal places after we've multiplied it by pi. Okay, so the volume will be, let's write that up the top here. So the volume of this thing, okay, the volume will be approximately 711.47 to 2 decimal places, 0.47, alright, 2 dp. Now these will be cubic units, but you can see here that by starting off with a simple idea of cylinders, we can actually estimate it with some cylinders. Roughly, firstly it was done fairly roughly. Then if you do it more precisely, you actually increase the number of cylinders, hence obviously their widths would shrink, and as you let the number of cylinders head off to infinity, or the widths of them to shrink, the height becomes delta x and eventually dx, and then we can actually generate the formula, which is basically around the x-axis. Obviously you can do this around the y-axis as well, but around the x-axis the volume formula is volume equals pi, the integral normally from a to b along the x-axis of fx squared dx. Now if it was around the y-axis, it would be the volume equals pi integral maybe from c to d of f of y squared dy, because we are, you know, circular cross sections. This sometimes is called discs, the integration by slices or discs. Okay, well, thank you for watching. Bye.